Hey everyone, we're going to start this video with number 13. Mr. McConey did number 12 in the previous video. So this is still going to be using the law of sines and cosines. And so if I draw triangle ABC, again, it has to be oblique. It doesn't matter how you draw as long as there's no clear right angles. It just looks like a general triangle. A represents the side across from angle A. So this is 11 centimeters. The side across from B is 8 centimeters, and the side across from C is 4 centimeters. And so you're given side, side, side. Now, unlike the last problem, where we had to use law of sines first, this time we're given no angles. And so if we're not given any angles, we cannot use law of sines. So this leads me to believe that law of cosines is the best way to start this problem. And when we use the law of cosines to start, the suggestion is always to find the largest angle first. And angle A is the largest because it's across from the largest side. So I'm going to write a note. We are going to find the largest angle first. And so the law of cosine looks like this. If we're looking for angle A, it is A squared equals B squared plus C squared minus 2BC cosine of A. The side that is across from the largest angle is always starting the problem, and the angle is ending the problem. And so let's plug in what we know. We know that A squared is 11, so 11 squared equals 8 squared plus 4 squared minus 2 times 8 times 4 cosine of I don't know, so cosine of A. So that's what we're trying to find. Because if it asks me to solve the triangle, I need to find all the remaining pieces, which are going to be 3 angles. And so if my goal is to solve for A, let's first simplify this a bit. 121 equals 64 plus 16 minus 2 times 8 times 4, or 16 times 4 is minus 64 cosine of A. And if my goal is to get cosine alone, let's move the non-attached things first. So let's subtract 64 and 16 over here. If I do that, it would become 41 equals negative 64 cosine of A. Now I want to reiterate to you that all of these numbers are multiplying cosine A, which is why I did not move the 64 yet. But now would be a good time to do so. You divide both sides by negative 64. We would get, let me put cosine over here, we would get cosine of A equals negative 41 divided by 64, or 64 divided by, or 41 divided by negative 64. In the calculator, that would be this as a decimal is negative 0.640625. If I take the inverse of both sides, I would get that angle A is the inverse cosine or the arc cosine of negative 0.640625. Make sure that your calculator is in degrees. And if you did that correctly, the angle you should get is 129.84 degrees for angle A. Because this is not the law of sines ambiguous case, we do not need to find the supplement. We do not need to check for 2 triangles. But we do need to find the remaining angles. So let's look back up at our triangle. And actually, I think at this point, I'm going to use this space over here for number 12 to keep going. So angle A was 129.84. So we know this piece. Let's next try to find angle B. Now that I know that angle A is 129.84 degrees, I can use law of sines again because I have an angle across from a side. So let's set up this proportion. Sine of 129.84 degrees over 11 is equal to sine of I don't know, B, over the side across from it, which is 8. Let me make sure that looks more like an 8 there. So if I cross multiply, I would get that sine of B, sorry, pen is freaking out here, sine of B is equal to 8 times the sine of 129.84 all divided by 11. If I plug this into the calculator, I would get that sine of B is equal to this loveliness, which ends up being 0.57621, blah, 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 blah. If I take the inverse of both sides, I would get the inverse sine of 0.57621, and angle B, when plugging into the calculator, should be 33.95 degrees. So I found angle A, I found angle B, and so to find angle C, all you have to do is 180 degrees minus 33.95 minus 129.84 to find angle C. So angle C, if subtraction done properly, would be 16.21 degrees. Sorry about the handwriting on this. Hopefully for the next example, the computer starts to work again. That'd be exquisite. Numbers 14 and 15 are going back to Chapter 5, and these are specifically asking you to write as a single trig function, and these look like sum and difference formulas to me. So I'm going to write a note so we have sum and difference formulas. This one, when it goes cosine, cosine, sine, sine, that is going to be cosine of something. And what I would suggest at this point is if you do not have your identity sheet in front of you, I would please get it in front of you. This relationship that I see, cosine, cosine plus sine, sine, is the same as cosine of A minus B, which in this case would be cosine of 285 degrees minus 60 degrees, which is really cosine of 225 degrees. So remember that cosine means what is the x value at 225 degrees? Well, handy dandy Google here has a unit circle, and I know you have one on a reference sheet. 225 degrees is the same as 5 pi over 4. So the x value at 5 pi over 4 is negative root 2 over 2. So my answer is negative root 2 over 2, because that is my x value at the angle 225. 15 is also a sum and difference formula, except for it's now a sum and difference for tangent. And if you look at your identity sheet, when you have subtraction on the top and addition on the bottom, that is the same as tangent of x as x minus y, or tangent as a minus b, however you want to think of it. So that would be tangent of a, which is 3 pi over 4, minus b, which is pi over 12. Here, we would need a common denominator, so we would multiply the first one by 3 over 3. We would get tangent of 9 pi over 12 minus pi over 12, which is tangent of 8 pi over 12, which is more commonly known, taking out a GCF, of tangent of 2 pi over 3. So we're trying to find the tangent value, or y over x, at 2 pi over 3. So if I go back to my unit circle, 2 pi over 3 is in the second quadrant. If I take root 3 over 2 and divide it by negative 1/2, that is going to be root 3. Some of you might remember from semester 1 that we have root 3 over 3, 1 root 3. So this would be root 3 as well, except it's in the second quadrant, so it should be negative root 3. So my tangent value at 2 pi over 3 is negative root 3. If you don't believe me, feel free to take the y divided by x, or to take root 3 over 2 divided by negative 1/2. If you do, you'll get negative root 3. Write as a complex number a plus bi. Well, this seems like a conjugate problem to me. We can't have i's in the denominator, so we have to multiply top and bottom by 7 plus 4i. And if I do so, it ends up being FOIL on the top and bottom because of a binomial times a binomial. So if I do that work, I would get 14 plus 8i minus 21i minus 12i squared. Be careful to not forget the squared there. All over. The reason we use the conjugate is so that our middle terms always cross out. And so we would only have to multiply the first and last, which would be 49 minus 16i squared. So if I simplify a bit, we'd have 14 plus 8i minus 21i. Remember that I squared is really negative 1. So if this is replaced with negative 1, this really becomes a plus 12. And in the denominator here, we would have 49. And then again, we have I squared. So this becomes plus 16. So 14 plus 12 is 26. 8i minus 21i. gets me negative 13i all over 49 plus 16, which is 65. Is there a greatest common factor in all of these? No, there's not. But because this is an imaginary or complex number, we want our answer to be a plus bi. So the best way to write this answer would be 26/65 minus 13i over 65. Correct answer in complex format. Last but not least, for number 17, you're to solve this quadratic and pick whatever method you think is best. Now, the first thing I would try is factoring. Are there two numbers that multiply to be 11 and add to be 20? No. So factoring, any kind of factoring is out. Square roots. Can I take the square root of both sides? No, because these are not like terms. See you later. So we're between completing the square and quadratic formula. In fact, you can do both. The first one I'm going to do is completing the square, because I like the fact that my lead coefficient is 1, and I also like that my middle term is even. So if you're a person that likes completing the square, let me do that first. If you are to complete the square, what you have to do is first move the 11 to the other side, and then you would add the special number on both sides. So plus blank, negative 11 plus blank. The special would be the b over 2 squared, which is 20 over 2 squared, 10 squared, or 100. So this side becomes 89. This side is factorable. Perfect square trinomial here becomes x plus 10 quantity squared. You then would take the square root of both sides. X plus 10 would equal plus or minus root 89. So your answer would be negative 10 plus or minus root 89. Now, if you are a quadratic formula fan, instead of completing the square, let me do that as well. X equals negative b plus or minus the square root b squared minus 4 times a, which is 1, times c, all over 2 times a. X equals negative 20 plus or minus the square root. 20 squared is 400, minus 4 times 1 times 11, minus 44, all over 2. So x would equal negative 20 plus or minus the square root of 356, all over 2. So 356, let's see, is that divisible by 4? Yes, it is. X equals negative 20 plus or minus root 4 times root 89. Let me just double check that. 4 times 89, yes, all over 2. So x would equal negative 20 plus or minus 2 root 89 all over 2. If I simplify this triangle of numbers and divide everything by 2, I get my answer as x equals negative 10 plus or minus root 89. So either way, you get the same answer. I would say, though, for time on a test, I feel like it took me a lot less time to do completing the square than quadratic formula. But I know under pressure, sometimes some of you might prefer quadratic formula, so I want to show you that both are possible. So I'm going to write completing the square as an option, or quadratic formula. All right, guys, again, I hope this video was helpful. Feel free to rewatch any piece that you need. Thank you.